Welcome to Azure Simplified. Table of Contents. Introduction to Data Storage. Overview of data storage and management. Types of data storage based on structure and access. Understanding data organization. Structured versus unstructured data. Data accessibility for different users. Case study, Tailwind Traders. Company overview. Storage challenges and requirements. Exploring storage solutions. Azure storage accounts. Blob, file, and disk storage for unstructured data. Balancing features, performance, and cost. Designing for data storage. Strategies for effective data storage design. Azure storage solutions. Azure storage accounts. Azure Blob Storage. Azure Files. Azure managed disks. Ensuring data redundancy. Importance of data redundancy. Techniques for data protection and durability. Storage security best practices. Implementing security measures for data storage. Design for data storage. 1. Identifying data types for storage needs. The first step in designing Azure storage is identifying the types of data required. Data is classified into 3 categories. Structured data, stored in relational databases with tables, rows, and keys, e.g., medical records, financial accounts. Semi-structured data, less organized, using tags and serialization languages, e.g., HTML, JSON, XML files. Unstructured data, the least organized, with no clear relationship, e.g., media files, text documents. Storage options for non-relational data in Azure. Different storage objects are available for non-relational data. Azure Blob Storage, best for storing large amounts of unstructured data, such as multimedia files. Azure Files, provides managed file shares in the cloud, accessible via SMB, NFS, and REST API. Azure Managed Disks, block-level storage for virtual machines, similar to physical disks. Azure Queue Storage, used for storing and processing large numbers of messages asynchronously. Each option caters to different storage needs within the Tailwind Traders organization. Design for Azure Storage Accounts. 1. Creating Azure Storage Accounts. Once data storage requirements are determined, storage accounts need to be created. Azure Storage Accounts group together all Azure storage services. Provide a unique namespace accessible over HTTPS. Ensure data is durable, highly available, secure, and scalable. Require multiple accounts for different settings like location, replication, and compliance. The following illustration shows 2 storage accounts in the Tailwind Traders organization that differ only in the data location region. But this one difference is enough to require separate storage accounts in the infrastructure. 2. Types of Azure storage accounts. Each storage account type supports different services and has unique use cases. Standard General Purpose V2 supports blobs, file shares, queues, tables, and disks. Recommended for most scenarios. Premium block blobs, optimized for high transaction rates with low latency. Ideal for smaller objects requiring fast access. Premium file shares, high performance file shares for enterprise applications, supporting SMB and NFS protocols. Premium page blobs, high performance storage for page blobs, suitable for OS disks, data disks, and databases. 3. Key considerations for storage accounts. Storage location. Place storage accounts close to users for efficiency. Compliance requirements. Ensure adherence to legal and regulatory guidelines. Cost management. Choose settings that align with budget constraints, e.g., geo-redundancy increases cost. Replication strategies. Use different accounts for critical, geo-redundant, and non-critical, locally redundant data. Administrative overhead. Consider the complexity of managing multiple accounts. Data sensitivity. Secure proprietary data with virtual networks while keeping public data accessible. Data isolation. Maintain separate storage accounts for compliance, regulatory needs, and application segregation. By carefully considering these factors, organizations can optimize its Azure storage strategy. Summary 1. Importance of data redundancy in Azure storage. Azure storage ensures multiple copies of data are maintained to protect against failures, outages, and disasters. Data redundancy helps meet availability and durability targets. 2. Types of data redundancy. Data redundancy is implemented through replication in a primary region and optionally in a secondary region. Primary region redundancy options. Locally redundant storage, LRS, low-cost option storing 3 copies within a single data center. Protects against hardware failures but not data center failures. Zone redundant storage, ZRS, replicates data across 3 availability zones within a region. Ensures continued access even if one zone fails. Secondary region redundancy options. Geo-redundant storage, GRS, asynchronously replicates LRS data to a secondary region. The secondary copy is only available during failover. Geo-zone redundant storage, GZRS, asynchronously replicates ZRS data to a secondary region. Offers higher resilience than GRS. Read-access geo-redundant storage, RA-GRS, read-access geo-zone redundant storage, RA-GZRS, allows read access to the secondary region before failover. 3. Considerations for organizations. Primary replication options, balance cost and availability based on business needs. LRS usage, suitable for non-critical data that can be reconstructed if lost. ZRS usage, ensures data remains accessible during temporary failures but may not survive regional disasters. Secondary regions, essential for high durability applications needing disaster recovery. Read access requirements, enable read access redundancy, RA-GRS, RA-GZRS, for applications needing continuous data availability. By carefully selecting redundancy strategies, organizations can optimize data availability, cost, and disaster resilience. Design for Azure Blob Storage. Summary. Design for Azure Blob Storage 1. Key considerations for Azure Blob Storage. Choose an appropriate blob access tier based on availability, latency, and cost. Decide if immutable storage is needed for data protection. 2. Azure Blob Storage access tiers. Each tier balances cost, availability, and latency. This table describes the different Azure Blob Storage access tiers, which allow you to balance cost, performance, and availability based on how often you need to access your data. Key considerations. Hot tier is the most expensive per gigabyte but has the fastest access. Cool and cold tiers have lower costs per gigabyte but require data retention for a minimum period, 30 or 90 days, to avoid early deletion charges. Archive tier is the cheapest but has high latency, hours, since data must be rehydrated before use. Choosing the right tier helps optimize storage costs while ensuring data is accessible when needed. 3. Azure Blob Immutable Storage. Immutable storage protects critical data from modification or deletion using write once, read many, worm policies. 2 types. Time-based retention, prevents deletion or modification for a set duration. Legal hold, locks data until manually cleared, typically for legal compliance. 4. Implementation considerations for organizations. Availability, determine if instant access, hot, cool, or delayed access, archive, is needed. Latency, critical workloads may require low latency premium blob storage. Cost, hot tier has higher storage costs but lower access costs, while cool and archive have lower storage costs but higher retrieval costs. Immutability, implement retention policies or legal holds where data protection is essential. By selecting the right storage tier and immutability settings, organizations can optimize cost, performance, and security for their data. Design for Azure Files. Summary. Design for Azure Files 1. Key features of Azure Files. Fully managed cloud-based file shares accessible via SMB, NFS, and REST API. Supports cross-platform access, Windows, Linux, Mac OS. Secure with encryption in transit and at rest. Highly available with built-in redundancy and backup options. 2. Access methods. Direct mount. Use SMB, NFS to mount shares in Azure or on-premises. Azure File Sync. Cache Azure file shares on premises for fast access. 3. Performance levels. Standard performance, HDD-based, lower cost, moderate performance. Premium performance, SSD-backed, high IOPS, low latency. 4. Azure File Storage Tiers. Premium tier. Uses SSD storage, providing high IOPS and low latency. Suitable for performance-intensive workloads like databases, web hosting, and DevOps. Transaction-optimized tier. Uses HDD with moderate performance. Ideal for workloads with frequent read, write transactions, such as business applications. Hot access tier. Uses HDD and provides general performance. Designed for frequently accessed files, like team file shares and collaborative environments. Cool access tier. Uses HDD but is optimized for cost efficiency rather than performance. Best for long-term archival storage and files that are rarely accessed. Azure Files versus other storage solutions. Best for Azure Blob Storage, optimized for large-scale, read-heavy applications like analytics, media streaming, and backups. Azure Files, designed for shared file storage, databases, and traditional applications requiring SMB, NFS. Azure NetApp Files, best for enterprise NAS workloads needing high performance and low latency. Protocols. Azure Blob Storage supports NFS, Network File System, and REST APIs for object storage access. Azure Files Supports SMB, Server Message Block, NFS, and REST, making it suitable for both Windows and Linux environments. Azure NetApp Files supports NFS and SMB, providing seamless file sharing capabilities for high-performance enterprise applications. Performance. Azure Blob Storage offers up to 20,000 IOPS, suitable for data-intensive workloads. Azure Files provides up to 100,000 IOPS, supporting enterprise-level file sharing and databases. Azure NetApp Files delivers the highest performance, up to 460,000 IOPS, ideal for low-latency applications like SAP HANA and high-performance computing. 6. Key considerations for organizations. Workload type. Choose Azure Files for general file shares, Azure Blob Storage for scalable object storage, or Azure NetApp Files for performance-sensitive workloads. Performance needs. Use premium storage for high-speed workloads, cool tier for archival data. Access and security. Use Azure File Sync for on-premises caching and encryption for secure storage. By choosing the right Azure Files implementation, organizations can optimize performance, cost, and security for their storage needs. Design for Azure Managed Disks. Summary. Design for Azure Managed Disks 1. Overview of Azure Managed Disks. Used for storing data in Azure Virtual Machines, VMs. Supports up to 32,767 GB per disk. Microsoft recommends using managed disks for easier management. 2. Comparison of managed disk types. Ultra Disk. Best performance, lowest latency, for enterprise databases and real-time processing. Premium SSD. High performance, but slightly lower than Ultra Disk, for transactional databases, business-critical apps. Standard SSD. Balanced cost performance, for general workloads like web servers, dev, test environments. Standard HDD. Lowest cost, slowest performance, for backup and rarely accessed data. Choosing the right disk type depends on workload performance requirements, budget, and how frequently the data is accessed. 3. Encryption options. Azure Disk Encryption, AID, encrypts the VM's virtual hard disks, VHDs, ensuring only the VM can access them. Server-side encryption, SSE, encrypts data at rest at the physical disk level. Encryption at host, encrypts data on the VM host before sending it to storage. 4. Key considerations. Choose the right disk type. Select a disk based on required throughput, IOPS, and latency. Consider data caching. Read-write, default for OS disks, optimizes both read and write performance. Read-only, default for data disks, speeds up data reads. Disk caching not supported for disks is greater than or equal to 4 TB. Availability by region. Ultra disks may not be available in all Azure regions. 5. Recommendations for organizations. Mission-critical apps, Ultra disks or premium SSDs. General business apps, standard SSDs. Backups and archival data, standard HDDs. Security requirements, enable SSE or AID encryption based on compliance needs. By selecting the right Azure managed disk type and configuration, organizations can optimize cost, performance, and security for their VM storage solutions. Design for storage security. Summary. Design for Azure Storage Security 1. Overview of Azure Storage Security. Azure Storage Security provides multiple layers of protection, including firewall policies, encryption, access controls, and secure network configurations. 2. Key security features and best practices. This table provides an overview of key Azure Storage Security features and their descriptions. Below is an explanation of each security feature. 1. Azure Security Baseline. Grants limited access to storage resources. Ensures best security practices are followed to protect data. 2. Shared Access Signatures, SAS, enables granular control over client access. Defines permissions and expiration times for accessing storage resources. Useful for granting temporary access without sharing full credentials. 3. Firewall Policies and Rules. Restricts access based on IP addresses, subnets, or trusted Azure services. Enhances security by blocking unauthorized external access. 4. Service Endpoints. Restricts access to a virtual network. Ensures that storage traffic remains on the Azure backbone network, reducing exposure to public internet threats. 5. Private Endpoints. Provides secure private connectivity between a virtual network and storage. Uses private IP addresses to ensure secure communication. 6. Secure Transfer. Enforces HTTPS, TLS for all storage transactions. Rejects non-secure, HTTP, connections, ensuring data integrity and encryption in transit. 7. Encryption options. Data encryption is enabled by default. 2 types. Microsoft Managed Keys, default. Azure automatically handles encryption. Customer managed keys. Users can opt to control encryption keys via Azure Key Vault. This table highlights Azure's multi-layered security approach to ensure data protection, controlled access, and encrypted storage in the cloud. 3. Key considerations for organizations. Implement Azure Security Baseline to follow Microsoft's recommended security framework. Use SAS for temporary access to define strict client access permissions. Enable firewall rules to limit access to trusted IP ranges or Azure virtual networks. Leverage private endpoints for secure communication between storage accounts and VMs. Require secure transfer, HTTPS, TLS, for all storage operations, default setting. Use customer managed keys, CMK, via Azure Key Vault for enhanced encryption control. By implementing these security measures, organizations can ensure secure, controlled, and compliant storage access in Azure.